tough.
Hi everybody, welcome to Cosmo Daily Job Logs. So I have the honor of introducing me, Cole Fletcher. So a little bit background about Cole. So Cole has been in the foam industry for over 10 years now. He started out as an applicator back in 2010 with a large company in northern Alabama. He then worked his way in 2013 to become a traveling technician with a large insulation company. And over the years, he's worked up through working for a different chemical manufacturer, and now he works for Creative Polymer Solutions. He's trained and worked with thousands of people. Most of you probably all know him from his presence on the internet and stuff like that. But he's a great tech. He's a huge, huge part of this industry. So please give a round of applause and welcome Cole Fletcher.
Good morning, everybody. Thank you for attending this class this morning. Please bear with me. I'm just a little nervous. Kind of make sure I don't stumble my way through this. If I do, just please be patient with me. So over the course of the years, I have worked with anywhere from beginning entry-level people that are looking to get into the industry, all the way up to some of the most successful large corporate organizations that have hundreds to thousands of rigs on the road every single day spraying foam. And I was asked to do a topic and presentation on what I feel like our industry needs a step up in. And one of the biggest opportunities I think we have to make progress is documentation on a daily level. The reason I say this, now that I am a representative for a chemical manufacturer, there are warranties involved, there's technical support involved, there's questions, and some of the answers that we're required to provide, we need a snapshot of what your day looks like. You know, we manufacture the chemicals that go into the drums. But at the end of the day, when you're in that job site, you guys are the end product. You're the manufacturer. And if you've ever done any type of manufacturing facility, there's lots of procedures in place to make sure that there's consistency with the product. Well, I think that we've gotten to where we are complacent. And what I don't mean that in a bad way, but I think that we've been doing things a long time a certain way. And we may or may not have ever experienced a hiccup along the way, such as an odor complaint or homeowner concern where there's a product failure, or maybe even as far as a cosmetic concern that the homeowner's not happy with. So you get a phone call from the homeowner, and the homeowner calls you and says, "Hey, I know you guys installed product back in 6 months ago. I feel like my house is sweating, or I feel like there's an odor, I'm getting headaches." Any of the thousands of things that could potentially go wrong, whether it be the foam or not. Sometimes we know retrofit applications will install foam. It changes the health of the home in either a good way or a bad way. So if the homeowner continues to call you and wants to continue on the path of getting a resolution, you call your distributor or you call your manufacturer direct, and you get a hold of somebody like me. And it's my job to investigate what happened that day, if there is indeed a problem, right? So if you ever go to a job site and you've got a odor complaint, it is my job to take documentation and see what happened potentially that day. Anything from what your drums were stored at before you put them on your rig. We're talking, material supply pressure, filtration, pressurization, ratio, dispensing the material through the gun, pattern development, understanding lift thicknesses and limitations, humidity, dew points, substrate type, substrate temperature, moisture content. The list goes on. There's literally thousands of variables that can change 5, 6, 7, 8, 9, 10 times a day. It is our job at the end of the gun, or the lead guy on that job site, to make sure that the material is being processed within a spec window, and that within that spec window, we try to find where that combination of pressure, temperatures, distance, and everything else will achieve the best quality product. Now, I would say that within our industry, and this is a relatively conservative number. If I were to look at all of the rigs I've been on in the past 13 years, I would say that there's 10% of the fleet actually doing daily documentation every day. It's a very scary thing to realize when every day something can go wrong. And a lot of times people have a misconception of off-ratio foam, for instance, being an immediate failure that's observed at the gun where we stop spraying and we reevaluate the situations and we can fix the problem and then continue on our day. You know, sometimes that phone gets buried. Once the problem's been fixed, we go over that phone, which I feel is a bad thing. But what I'm getting at is you can be spraying and you can observe foam that is performing within what we would consider a performance window. That doesn't mean that things aren't going wrong. The foam can look presentable right now, or right then and there at the end of the gun. But I've been on job sites for 5 years later. Homeowner sells the house. Bank inspector comes in and says, hey, I seen one of your guys' installation certificates. I called the manufacturer. They don't, you know, they've sold the company. It's a different owner. You know, what can we do? And, you know, the company gets a phone call and, you know, there's shrinking foam in the attic. The attic is shrunk. We have condensation in the attic. At this point, we probably have mold and mildew. Well, I want to be able to come in and confidently say whether it was a product failure or an application failure. If we can identify one of those two things, as a manufacturer's rep, it is our duty to warranty delivered good goods, meaning that when the material got to you, it was within spec, within expiration. If I get a phone call and there's a shrinkage complaint, and I don't even know what the manufacturer was that was sprayed that day, because a lot of our foams look similar when they're finished. They're white, off-white. There's the majority of them, I think there's only 2 closed cell foam manufacturers that have pigment added to their foam. So I walk in and I see white foam and it's shrinking. Well, they think it was my foam, or maybe they think it was a competitor's foam. Without just the simple documentation of what that product was when that installation happened, that's where things can get sideways. All right. So we're going to go through a couple of scenarios. Basically, what I'm going to have is slideshows of talking points. At any time during the presentation, if you feel like you need to have a question answered, just raise your hand. I'll feel free to go through it. There's no, you know, necessity on what we need to talk about, as long as the majority of the topics get talked about. All right, the importance of daily documentation. Cover your butt. I was taught very early on with the company that I was working for, which is a huge corporate entity that has divisions all over the country. And my mentor told me, one of the main reasons we do documentation is to cover our butt, because as a manufacturer of the finished product, the chemical manufacturer needs to feel confident that we've done our job. If they don't feel confident in us, like if there was something that went wrong that could have been our fault at the gun, they're gonna bring up these objects. It is my job to come in, right, and investigate what it is that's going on. And in reality, 90 to 99% of the problems are operator error, whether it be environmental, meaning you weren't paying attention to the environmental conditions, equipment failures, or information getting to the machine that was inaccurate, so machine calibrations, and just misunderstanding of product limitations, spraying it too thick, spraying it too cold, spraying it too hot, too much distance. These are the kind of things that will cover your butt. If I show up and I have a piece of paper that allows me to have a snapshot of your day, everything from storage of the material to the finished product and distance from the gun, these things can be looked at and say, you know what, everything on this documentation was accurate, it was within spec. Now we need to start investigating our end and looking at what we call a retain. A retain is a very small portion of the material that was made in that large batch that day or that, you know, that week. So cover your butt. We aren't just sprayers, we are mobile manufacturers. So we have formulation variants between manufacturer and manufacturer. So I know with COVID, things got a little dicey and people were spraying whatever they could get, right? So within that window, you may not remember what you sprayed last week, much less 6 months ago. So formulation variants could go from manufacturer to manufacturer, or even winter formulations, summer formulations, regular formulations, different speeds, different densities for 2 pound. You know, there's 1.6, 1.7, 1.8, 2 pound, 2.2 pound. We have equipment faults. You know, we rely on our equipment to give us accurate information to be able to diagnose and dial in our material. If anybody in here has followed me on social media, you'll understand that one of the things that I look at is hose heat accuracy. We would be shocked if we were to ever look at our rigs when we leave here today and see that the hose temperature reading was actually what the machine was displaying. I think if you leave here and you were to do a system bucket check and check the actual fluid temperature, you would see that there is a difference. So we are relying on equipment. So if we have equipment faults, we may feel like we're doing our job and everything is within spec, but if we don't verify that the information that that equipment is giving us we can have extreme failures, right? Or even in just inconsistencies in the pattern development or reactivity for that day. Equipment configurations, I deal with on a common basis, the three big companies out there. We've got PMC, Accurate, and Graco. Each one of those pieces of equipment can be sprayed and need to be handled differently, right? So we have equipment configurations. Environmental influences, especially in the coastal regions, we can have 30-degree mornings with frost on the ground. We can have, fog in the air till noon, and it can be 100 degrees in the afternoon. These are the things that we need to write down on our piece of paper during our daily log. We're gonna have AM, PM, and there's typically 4 lines that every time you make a major adjustment, that is documented, as well as the environmental conditions for that adjustment. So if you go home and you build a daily worksheet, make sure that you keep in the back of your mind, there's at least 4 times a day where temperatures need to be adjusted due to environmental factors. But down here in the south, especially this time of year, you guys were here 2 days ago, it was blowing 30 degrees, we were at dew point, and it was 45 degrees. Come afternoon, it was sunny, birds were out, and it was 80 degrees. If we don't make adjustments during the day to accommodate those environmental factors, we could go from making perfect foam to making foam that will fail in the same 12-hour window. Substrate types, again, this is a big factor, especially if you guys ever dabble in South Florida or even in the light commercial segment. You may have a wood frame roof deck and a block or precast exterior wall that are both getting foam. So substrate types like concrete are going to spray and need different parameters than 1/4-inch OSB that's on a roof deck that's in the sun with black shingles on it. Substrate type is very, very important, especially when it comes to metal buildings. You get in a metal building, and yesterday you got the machine and the foam dialed in for 3/4-inch OSB on a sunny side of the building. You show up tomorrow, environment's at dew point, you're spraying on 12 gauge or 14 gauge metal, that foam is going to react differently. There's no ifs, ands, or buts about it, so we have to document that. Drum conditioning, when we're processing foam, we need to know what that chemical was at in the drum. The reason being, there are temperature ranges that we recommend, and we recommend temperature ranges due to viscosity of the material and the delta T potential of what that drum is going to be sitting at and what our material sprays at. For instance, if we have a material that is around the 140 degree range, Mark, you've sprayed a couple of these 140, 145 degree foams, right?
Yes, sir.
Their recommended drum temperatures are going to try to accommodate that difference in temperature, delta T, right? So if I have a foam that sprays at 140 degrees, my recommendation is going to be a 90 to 95 degree drum. If I have another product that sprays at 100 to 105 degrees, my starting point may be 65 to 75, 85 degrees in the drum. On top of that, we have viscosity issues. If we have a material such as closed cell in the drum at 60 degrees, it is going to be 4 times thicker than it will be at 75 degrees, okay? 100 degrees or 10 centipoise per degree, I believe. Yeah, so for every degree increase in that drum, you will thin that material up by viscosity of 10, all right? Water is viscosity of 1, so if you can imagine water and times it by 10, that's what you're gonna gain or lose with viscosity every time you add or subtract a degree in the drum. So we have to make sure we document that. Processing parameters, when we're spraying, what is the machine set at? What is the inlet pressure? What is the machine target temperatures? What's our dynamic and static pressure? We do want to document static and dynamic. Dynamic is when you are under flow, so when you're on the trigger, that machine is going to be cycling. The lowest number that your gauges achieve is what gets written for your dynamic pressures, because you made foam at those pressures. A lot of us get in the mindset, if I set my machine at 1,200 pounds, I think that I'm spraying foam at 1,200 pounds. But if you had somebody in front of the machine watching your gauges, I guarantee you, depending upon the system that you have and the chamber that you're using, you could drop down to 5, 6, 7, 800 PSI, right? Now you're outside that spec window, but if you didn't know that, you would think I'm within spec. I'm at 1,200, we're good to go. So when you're writing your documentation, we want to know what that machine was set to, and we also want to know the lowest pressure achieved during flow applications with dynamic. The reason we want both of those is as your machine wears, if you have the same configuration in the gun, the hose length stays the same, and your typical processing is good, as that machine ages, the separation between static and dynamic will increase. Now you know that your machine is getting worn. It may be at a certain point. For instance, a Graco Reactor E30. If you run a 42 chamber most of the time, a well-built newer machine should have a 150 to 250 pound dynamic drop. If a year from now you start noticing a 400 or 500 pound drop, where seals are getting weak, check ball is leaking, something is wrong with the equipment. Again, documentation will allow you to track that material. It also allows you to get more familiar with what your equipment's doing on a day-to-day basis. Ventilation configurations. Most manufacturers have ventilation requirements, whether it be CFM or air changes per hour required. You also want to make sure that you're documenting your ventilation, especially for retrofit. One of the biggest things that you can do to have a failure is not ventilate an area in the home, especially a crawl space, because we don't think about it. If we're not ventilating and we have an odor complaint later on down the road, I can probably assume it's not an installed foam problem. More than likely, during the application, you weren't pulling negative pressure, ventilating that area, and the amines and the catalysts and fire retardants and everything that was in that aerosol material in the air didn't react out at the same completion or at the same rate as the thicker material you're spraying on the wall. If that doesn't get evacuated, that material will settle in soft fabrics, carpet, white drapes, couches, and now that house can have an odor, and it'll smell like amines, like a foam processing day. That smell that you all are familiar with will linger in the home, right? If you're leaving insulation, small amounts like under decking, when you do your removal, if you can't get the fiberglass that's under the deck that the HVAC is on, there's a potential that that's going to absorb odors, right? So you want to ventilate that area. If you're doing crawl spaces, we think that that hard deck is going to separate the environment above us. Well, typically what will happen, there's always going to be penetrations, whether it be around pipes, wires, HVAC systems, registers, whatever. That hot, humid air that we're creating during the spray process will get up into the atmosphere, go up through the floor, and get into the carpet padding. Now, you don't even think about it, but the homeowner calls and says, man, my home smells like foam, and my house had an odor to it, but now it's different. It smells like chemical. All right, well, let's see what happens. Let's do a site visit in a week. What's going on? If I have ventilation on my little ticket, that's probably one of the things I'm not going to really focus on. I might go straight to the foam and start doing core samples. Documented communications from the field. Again, Mark, being an old top build guy like myself,
Yes, sir.
if my sales guys needed to know something about the job, or my production manager needed to know something about the job, hey, I need a Baker scaffolding, or hey, turn left after the cow pen, not before it. Whatever it may be, fall hazards. If you're trying to communicate to the guys in the office, this is the perfect opportunity to have a note section. I need parts, part numbers, blah, 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 blah. Now, when you don't get your parts in time, or you don't get the tools required to do your job that next day, look, dude, I told you, right? This is unacceptable. We got to make something happen, right? We did it all the time. Any questions
Saves a lot
there?
of hassle. It really
Sorry?
does. It saves a lot of hassle.
It
Gives
does.
another
And-
eye telling you need something.
We're covering our butt as the installer that we did communicate our needs, right? If our needs can't be met, then it's on somebody else at that point. All right, so we talked about formulation variants. We've got open cell versus closed cell. Depending upon your marketplace, you may be predominantly one or the other. However, I would assume that everybody has sprayed open cell or closed cell at some point in time. When you're doing a changeover from open cell to closed cell or closed cell to open cell, make a note on your document, so that way that's one of the things that we can investigate during an odor complaint. Also, there's waste associated with a changeover. Make sure you document that so they can track the material used. Winter foam versus summer foam. If anybody's here is familiar with closed cell, we know that winter foam and closed cell summer foam sprays at different parameters. Make sure that we document that we said closed cell winter. Now, if you have your batch ticket, we could dig and figure out if it was open cell or winter or summer. But if it's there in a glance, I'm not even going to worry about it, because I know what I'm working with now. Differences in manufacturers. Again, during the pandemic, things got tough. People were spraying different foams. A personal experience, I got involved with an install concern, cosmetically, meaning inconsistencies, depths, whatnot. I get dispatched, I mean, you know, we're $2,500 a week in travel, whatever it may be, to go up and see this house. I walk in, I look up, and it's the wrong color. It's not even our phone, right? So these things happen. It'd be nice to document what manufacturer is being sprayed that day at minimum. Difference in substrate, or I'm sorry, changes in substrate type and temperature. If you're spraying in Florida, we'll have block foundation, block exterior walls, and wood roof decking. If you can make in your notes section, say, hey, started the morning off on the roof deck, finished my day on the block foundation. Equipment faults, identifying inconsistencies easier, and tracking of failed parts. So when you're documenting, like for instance, on the new reactor 2s, you have what's called resistance mode. When you calibrate, if you're noticing that every day you have to recalibrate or something is not right, keeping track of that allows your equipment tech to really dive in and focus on some of the problems instead of showing up and starting and just doing an investigation. If he's noticing that every day that you're recalibrating because your documentation states that, it's going to be easier for him to do his job. Tracking of failed parts. We talked about following your dynamic pressure drops. If you realize that at 400 PSI drops, maybe I need to start ordering parts, right? So my dynamic and static pressure start to deviate more and more. That 400-pound mark is my warning sign. Now I can order parts. Then when your supervisor doesn't order parts, again, it's part of that documentation from the field. It's all there. Again, these are more of the extra stuff to communicate. We'll focus on more of the pertinent, definite information. Equipment configurations. What's the equipment's limitations? You know, we've got E20s, E30s, H30s, H40s, H50s. We've got PH2s, and the list goes on and on. Documenting what that equipment was, a technician like myself can come in and look at, he was running an AR6060 with an E20. Automatically, I know that I'm gonna go back to my pressure differentials and look at my dynamic pressures. If he was being honest that day, we're gonna see that he was well below processing recommendations because that machine just doesn't have the fluid or the delta P to spray that material. So again, just keeping track of that. We've got delta T, delta P, delta pressure, pressure drop between static and dynamic. Hose length and PSI drop. A machine that has 100 feet of hose at 3/8 inch versus a system that has 410 feet of hose, both machines set to 1200 are going to have different pressures at the gun. Okay, the longer the hose, the more drag, the less pressure drop you're going to have. So again, if you're on an H30 or an H40 and you've got 410 feet of hose and your static pressure is 1000 PSI, I can assume that at the gun, you're well below that 900 mark. You're probably around 400 to 500. Sound right?
Yeah.
All right, also gun chamber and configuration and output. So let's say you're used to running an AR4242. Today you decided to run an AR5252 on that E20. If you have that written down, you'll remember that, dang, I normally run a 4242, so maybe I sprayed with a 4242 that day. But in reality, you switched over for a 52 because your gun went down. If you didn't have that written down, again, I'm gonna go and start looking at other stuff in that form. If it's right there, it makes everything a lot easier. Environmental influences, in my personal opinion, a contractor, a mobile manufacturer, this is where things can really go sideways because you can be within the parameters of the material, whether it be pressures, temperatures. You know, the air temperature could be on point, but if you look at your humidity for that temperature, if you're at dew point, you have water in the air. Especially spraying a roof deck, you are taking a hot atomized material where 50% of that, the isocyanate, reacts with water. It's H2O. You're creating a carbon dioxide gas. So that material traveling through the air does two things. It's a dense air, so it's going to suck the heat out of the pattern, but you're also going to be adding a residual H2O to the chemical reaction. You can actually chemically change and alter the finished product because you sprayed through air that was saturated with water. So dew point, especially down here in the southeast around fall and spring, we can wake up in the morning. I've been on job sites where I couldn't spray till 1 o'clock in the afternoon because there was just a fog bank in the house. You go over to the roof, you wipe it down and it's wet, all right? So humidity, dew point, air temperature is a big one, because if your air temperature is at the edge of your processing parameter window, the distance between the gun and the substrate, air temperature can affect that. So if you're a guy that sprays, 36 to 42 inches away from a roof deck, and your air temperature is at the edge on the cold side, if you close the gap, you're gonna retain more heat and be able to potentially process good material. As to where if you back up, you may lose so much temperature that once it starts to react on the substrate, it's gonna become friable, which is a cold temperature reaction, a side effect of that. As well as air movement, especially roofing guys. Obviously, if you're spraying in anything over a 10-degree or a 10-mile-an-hour wind, you've been there, you've done it, you've seen 50% of your pattern go that way. All right, so if your coating starts having issues because of the overspray, we can identify that. Different substrate types: OSB, sheet metal, heavy metal, concrete, wood, pressure treated. So on my documentation, I have substrate type. The reason I have substrate type is if you spray, for instance, let's say pressure treated. Typically, fresh pressure treated has a moisture content reading higher than 19%. If you're not checking moisture content, but I see on your paperwork it says pressure treated, the first thing I'm gonna do is do a core sample and look at the back of that foam. I'm gonna look for delamination and strings, right? Because at the time, your moisture content was potentially, not necessarily, but potentially higher. And that's where we will be relying on the additional information, which is moisture content, right? So if you're on a job, I think sometimes in Florida, they do the treatment. Do they do the green spray around the bottom? I know in Alabama we did.
Yeah.
If you're walking around with your moisture meter and you're checking at chest height, you need to be looking down and checking at the bottom, especially under windows, around doors, anywhere that the potential for moisture content can be higher, especially pressure treated. If you're spraying on sheet metal, if you call me and say, hey, I'm spraying a metal building today, and I give you a window and come to find out it's a Connex box that's 1/8 inch thick steel, I may have been considering some very thin gauge exterior wall material that's for steel buildings. Those two things are gonna spray completely different. The reason that we do that is heat sinks. What we rely on is the additional heat caused by exotherm in the reaction to get the material to blow and then to finish the cross-linking process and allow it to finish out. If you spray on a thick metal such as a Connex box on the shady side of the container, the heat might be sucked out faster than it can be created, and then you're gonna have foam that hasn't finished out. You're gonna have extreme odor problems, you're gonna have lamination problems, blistering, you're gonna have all sorts of problems. So don't just put metal. Make sure if it's heavy metal, you put heavy metal on there. Concrete, for obvious reasons, we want to make sure that we're documenting this because high potential for moisture content. We can have blistering, we can have dirt and debris. Precast can have a mold release solution on it for when they cast the material. They want the molds to unstick. I think typically they use diesel or some sort of petroleum byproduct, I believe. And if I have a job site and I have a delamination and it's a precast, well, if you write down precast, one of the first things I'm gonna do, core sample, check adhesion, see if the sheets are delaminated. OSB, it's our most common material to be sprayed on. However, OSB, there's a certain manufacturer of board that is green, where some of their materials have something waxy, a wax coating, a non-stick or insulation release style material, but where they press these boards together through the rollers, it doesn't stick to the roller. That will transfer over to the wood and you can have delamination issues. So OSB, if it's a certain brand of OSB, write it down. So you've got zip panel, you've got Tech Shield, you've got a wide range of different materials. It's important that we document drum conditioning. It is manufacturer and even formulation specific. For instance, there are certain manufacturers of open cell foam out there where you need a special mixer, right? So if you don't document that you're using the special mixer and I'm coming in to do an investigation, I'm gonna ask to see your equipment and see what kind of mixer you're using. They have helical style, they have expanding blade style, and some are good, some are not. We also wanna make sure that we're storing the material. If you're storing material at your warehouse, we want it conditioned, and the reason we want that is If you take a drum that's 50 degrees and put it in the back of a rig that's 75, 85 degrees, it may never get to that bottom recommended temperature sitting in there and passively heating up. It's my recommendation that at your facility, you have a designated storage facility that sets that material up to where when it leaves the facility, it is close to target, if not at target, especially closed cell. I believe I did a study at a 75-degree room, it takes about 1 hour per degree. So you're looking at 24 hours sometimes to get your drum material up to temperature. And closed cell foam, I do not recommend that you circulate that drum to heat it up. Barrel blankets, for instance, like power blanket, they are designed to maintain that temperature, not necessarily increase the temperature. When it comes out of your storage facility, it goes on your rig, it needs to be treated kind of like a temperature maintaining device. And when you're recirculating your temperatures to condition that drum, document that down, because there are a lot of open cells, unbeknownst to some people, that when you recirculate at what your target temperatures are for spraying, for instance, if you spray at 140, tomorrow morning you go to recirculate your drum and you recirculate with those primary heaters at 140, you will damage the catalyst package inside that foam. And now when you try to spray it, it's gonna react slow, drippy, it's gonna be awful. You're gonna compensate with increasing your set temperatures. Now it's not dripping, but now the back end is so fast that the foam starts to shrink. So drum conditioning is an extremely important portion that we need to keep track of. Obviously, processing parameters. So manufacturer specific, blend specific, processing temperatures, processing pressures, hose length, and chamber size. Manufacturers have different formulations within their organization. There's one company here, I believe they have like 10 different formulations with similar names. So be very mindful that if you tap into a new set of foam, especially during a trial period where you're maybe potentially working with a new product, don't just put the manufacturer's name. It has to be documented the product specific name. Right? I'm not going to mention some, but a lot of times I'll get a document and it'll be the manufacturer. Well, that doesn't help me because I don't know which formulation it was. Blend specific. So formulations like for closed cell, some manufacturers have Arctic or polar, winter, regular, summer, Arizona blends. Some manufacturers have 5 different closed cells, especially in the roofing world. They could have more than that. Processing temperatures, this seems like a no-brainer, but we need to know what you were spraying at that day. Every manufacturer has a bracket in which that formulation needs to be sprayed at. We need to know where in that bracket. Yes, we give you a recommended window, but depending upon your environmental and substrate conditions, it could be at the bottom, it could be at the top, it could be multiple temperatures within that bracket. Be specific, and if you make adjustments, right, maybe not in the morning when you're trying to find the rhythm, but once you find it to where it's settled in, write that temperature down, and then a few hours later, if you need to make an adjustment, write that down. Processing pressures, this is extremely important. Again, paying attention to static versus dynamic. Don't just write your set points because that's not where you're making foam. Hose length, we touched on this earlier. A system at my plant has 50 feet of hose. We can spray material at 1,000 PSI dynamic, and it is going to spray 100% differently than a system with 300 feet of hose and a set point of 1,000. Totally different system. Another thing, yes?
How much PSI did you say you lose per foot?
So it depends on the configuration. So you can run 1/2 inch hose to 3/8 hose to 1/4 inch hose.
Right.
There's really no safe answer for me to give you because your dynamic drop at the gun compared to your gauges, there's thousands of variables to affect that. So really and truly, that's why you see some of these new manufacturers taking pressure readings towards the whip, towards the gun. What I would recommend saying is your dynamic pressures need to stay high enough to create good pattern development and good mix. This is why it always falls back on us as the finished goods manufacturer to test the foam, do density checks, do cell structure investigations and stuff like that. But also elevation, right? If we're going up 40 feet in the air, we're gonna lose a lot of pressure. If you guys want to, just take a simple online course, what's called fluid hydraulics. and it'll tell you what to expect on distance, length, elevation, diameter, viscosities, and stuff like that. Yes, sir. What's up?
On some of the newer systems that are running like 3/8 O's, and then they reduce back down to 1/4 inch, you're
Right.
gonna gain in that last 20 feet. Are you gonna gain some of your dynamic back?
So what the idea is that you're gonna gain dynamic pressure because you're restricting it, you're adding back pressure. Well, the gun kind of already does that with impingement ports, right? So yeah, I would say that it actually is counterproductive for us to increase or decrease diameter before the gun. Really and truly, if you look at the way the energy is being delivered to the impingement ports, that's where your restriction needs to happen, not 20 feet away. Because now, if the restriction starts back there, you've lost a lot of that dynamic energy before it gets to where it matters. I'm really hesitant on 1/4 inch whips over 10 feet.
You lose flow.
You lose flow, but your gauges at the machine are gonna recover some of that dynamic drop because it's thinking there's a restriction ahead.
That's kind of where I was going, is if you're looking at your gauges to get your dynamic pressure.
But you're kind of
are you
messing up.
actually getting a false read?
Yeah, you're kind of hurting yourself. Yeah, it makes it look better because you're getting some of that pressure deviation back. But you need that pressure deviation to happen at the impingement ports, not back there. So I've seen guys that are running 20-foot, 30-foot whips, and it makes me nervous. Now, if you're mindful of that, run higher dynamic pressures at the machine. You know, instead of 1,000, run 1,500, right? Again, comes back to us to making sure our temperatures are right, pattern development, reactivity. If the foam feels good, looks good, and you're inspecting the foam and you're taking odor sample tests every once in a while in a little Ziploc baggie, it's gonna determine, you're gonna have to determine where you feel confident at. Get a technician out to help you find that sweet spot and we'll help you. And that way we can see it together. Because we know what our formulation should be doing at a certain temperature and pressure. If we think the machine it's presenting good information, but what I'm seeing isn't right, we need to start considering maybe that whip is too long, right? So yeah, that's you do gain pressure, but it's false pressure. It's a false sense of security, right? Yeah. Does that make sense?
If we're documenting the dynamic pressures,
Yep.
are we actually documenting a faults?
Yeah, so here's what's gonna happen. Let's say you have 300 feet of hose and you're running off the main line, 3/8 inch all the way. And you have a 200-pound dynamic, 400-pound dynamic drop. You throw a whip on there, and now you've got a 200-pound dynamic drop. You think you're doing better, but what you've done is you've created so much drag. Now that once it's gotten past that 20 feet or 10 feet, you've lost energy at the impingement ports, and that's where it matters. Everything matters when the collision occurs inside the chamber. We need as much energy there as possible. Does that make sense?
Yeah.
All right, cool.
Now, do you have a recommendation for my guys, like what webpage they should do that fluid dynamics?
Just Google fluid dynamics chart, and you'll be able to type in, I think it's been years, I did it in the fire department where we talked about hydraulics and diameter and elevation and stuff like that. But it's not gonna give you an answer. It's gonna give you the tools to kind of make a better judgment. It's gonna educate you on what you need to look for. Does that make sense? All right.
Cool. So the new boss, very, I don't know, people feel a certain way about it, but the new double gun, the little addition boss system,
Yeah.
how does that change with like pressure, is that?
Well, so.
Will any manufacturer warranty
No,
homes?
I can't answer that. I don't know. So without getting into the weeds on the 2-gun system, at its core, you've doubled the machine output. You've cut the delta T potential in half. Your dynamic differential is going to increase by 2-fold. You need to look at the machine and get a baseline static pressure flow through both machines, both guns. Look at what the heat capacity is acceptable. And at those flow rates, again, you went from a 42-42 to an 84-84 in theory. You may be pushing that machine's capacity beyond what is acceptable. So, there's a lot of data that's not available yet. We're still in the early stages of investigation on whether or not that system's compatible with certain systems. At this current moment, we're not gonna warranty the product over at CPS only because we don't know, right? And that's the assumptions that are being made. So there's really no hard evidence until flow meters and we're measuring pressures at the gun. Just as a contractor that's manufacturing on a mobile site, pay attention. And that's all I have to say about that. Yeah. Any questions on processing parameter documentation? Ventilation configurations. All right, so this is another weak spot. I don't think people understand how important it is to ventilate a job site. Well, we have two things that you need to consider: reoccupancy and re-entry. On your work ticket, I feel that it's very important to document what type of ventilation configuration is needed for that job. And certain manufacturers, we're going to use industry standard. 1 air change per hour for 12 hours for re-entry, 1 air change for 24 hours for reoccupancy. Does anybody in here not know the difference between re-entry and reoccupancy? Because it's a big difference, okay? Re-entry is for trade work or people that are there to work on the site. Reoccupancy are for people that are going to work there for extended periods of times in an office setting, or they're going to be living at the residence, okay? Also, occupancy can even mean storage. If you're storing goods or household items, that is a reoccupancy situation. So let's talk about the 1 air change per hour scenario. I feel like this needs to be written down, and the way that you get this number is you take the cubic volume of this spray zone, length times width times height, divide that by 60. That will give you your minimum fan size to achieve 1 air change per hour. Some manufacturers, if you do 10 air changes per hour, your re-entry time is reduced to 2 to 4 to 6, whatever. I think there's a 1 hour. But if you're going to want to achieve those advanced re-entry times, it is very, very important that you're doing a ventilation calculation. And for a 10 air change per hour, it would be volume divided by 60 minutes times 10 air changes per hour. That answer that you get is your minimum fan size required to ventilate that job site. Again, if you don't ventilate, your potential for exposure goes up. So when you've got your skin exposed, all that particulate in the air will get on your skin and it can expose you to isocyanates and polyols and catalysts and all the other good stuff. Ventilation gets that out. So it's important that we document that. Yes, sir.
So how do you apply that to like a large industrial building?
So large industrial is going to be handled in segments more than likely. You're cordoned off an area 50 by 50, whatever you may be. If it's a very large industrial facility, especially if there's a lot of airflow, you could potentially rely on what's called passive ventilation, where you've got bay doors at both ends of the building and you've got crosswind. However, if it comes down to it, it's recommended that every job has some sort of mechanical ventilation. Big shop fan, multiple shop fans, a gable exhaust vent, something. That way at least you're covering your butt and you can say you were ventilating. The thing with passive ventilation is you can't guarantee the wind's not going to stop blowing. So just put a fan on everything, is the way I see it. You had a question?
Yeah, I was just wondering about the exchange of ventilation. Do you have anything like that on your website, that we can refer to?
As far as how to get the calculation?
Yeah.
No. So that's just something, I would take a note. It's volume divided by 60 minutes times ACH required. And the reason we use 60 is air changes are based on hours. Fan volume is based on cubic feet per minute, 60 minutes in an hour. So volume divided by 60 times ACH required. Communications from the field, the production that's going to be done that day, we have to, obviously if we've got a multi-day job, we want to make sure that we document what areas of the building we sprayed, the footage, the rough estimate of what we've sprayed that day, the supplies needed, the equipment needed. There's multiple people in this room that are from the field. We know what it's like to show up to a house and it needs a 16-foot ladder. It needs scaffolding. It needs fall protection. It needs additional labor to help. These are the things that you're going to need to document at the bottom of your daily document. Failures encountered. It's very important. If you're spraying and you run out of material and you spray a cavity that has a 2-foot section of unmixed or unreacted or off ratio material, it is my recommendation that you say southwest master bedroom had to do a removal because we ran out of material. Just something so that way a year from now, if there's an odor complaint, hey, let's go to that corner. Let's see if they tore it out. If it's torn out, maybe that's all we need to remove. Because if that's the problem child, now we remove or we identify and remove the one segment of the building that was the problem, we can fix the problem. Otherwise, I'm gonna say, well, how do we know that it wasn't the entire building potentially? So now we're gonna have to do investigation every 200 square feet, take core samples, put them in Ziploc baggies, and even then, you can't guarantee it's not somewhere else, right? So the recommendation becomes, it's all gotta come out. Failures encountered with equipment is always a big one. If you need a pump rebuild kit, let's say you're tracking your dynamic pressures every day and all of a sudden you're at 400, make a note, order parts, rebuild kit, need a maintenance day scheduled, right? Again, your production manager or your dispatcher or whoever's sending you out every day, even if you're an owner operator, you know that we've got so much going on, we might need a constant reminder of stuff that we need, because if we needed that part today, we need O-rings, right? You may forget until somebody mentions it again and it's a week later and now they're on a job site, they don't have parts, okay? Hazards encountered, one of the big ones is knob and tube wiring. The company that I used to spray for, if knob and tube wiring was exposed and present, we were not allowed in that building until we had a signed letter from an electrical company stating that either they removed that product or the product was definitely not electrified. Rodents, believe it or not, going in a crawl space and there's a family of raccoons or a bear. Hazards can be anything from water to rodents. Hazards could be a permit required crawl space, which is a whole nother world in itself. Again, if you encounter a problem or a concern, write it down. Cover your butt. Don't get called out and saying, because we've done it, why didn't you tell me? Dude, I told you a week ago. I needed Dynasol, right? There's nothing worse than getting on a job site and you lose your last side seal and it's like, buff out the best one I got, right? Additional notes, again, guys, daily documentation is a snapshot of your day. If you think for just a half a second that it's something that needs to be communicated to the owner, the production, the ops manager, whoever, or the crew that's coming in behind you, just write it down. It makes it easier, it makes everybody's life easier. The big thing being that you have to assume every job is gonna have a failure. I know it sounds pessimistic, but I've been on jobs where a homeowner contacts us before they contact the contractor. And they say, hey, your product was sprayed in my house. It smells like foam. I can't get it out. We have ventilated, we've called ServPro, they've put fans in. We've done everything in our power to get this out. As the contractor, I want to make sure that we get out of this thing just as much as you do. If I come in and there's a complaint and I have everything on paper, right? Everything that would consider a processing influence, I have it. It is my job to decipher that information. If you're within spec, my reputation is on the line to defend you. We're gonna go into this thing together, and now we're gonna look at maybe there's a mechanical problem. And when there's an odor complaint due to mechanical problems, it is no longer the foams guy's fault. And that is something that we've done in this industry, is we have fallen on our sword many, many times because we're scared. You know, there's a foam odor, yep, we'll get out there, we'll fix it, we're gonna make it right. And then you end up tearing out a roof deck with foam that was perfect. Maybe it had a gap at the soffit, right? Maybe you had one little soffit area open on the windward side, and you know, twice a year, you would have hot, humid air enter the space. So we go up there, you know, the foam presented well. We go up there with an infrared camera, we find a hot spot or a cold spot, we fix the problem with a little can of Hilti foam. It's that simple sometimes. Sometimes, obviously, there are failures, right? Every manufacturer will tell you one of two things. Either they've never had a problem and they're lying, or we have problems and it happens. Especially when we're manufacturing products that have multiple products that we're relying on being good, right? It's just like making a cake. If I buy a carton of milk or a carton of milk is expired, I didn't realize that and I make a cake, that cake didn't work, right? But in my mind, I went step by step and we formulated and we blended and we made the best product that we thought we made. Sometimes material will present well during our QC process at the plant, and it gets out there on a truck and it experiences heat variations where it's 65 degrees, 100 degrees, 65 degrees, 100 degrees, and something happens. If you've done your job and I feel like you've processed it correctly, Now we need to investigate manufacturing problems, and it happens. So make it easy on us to self-support you and to get the homeowners, you know, confidence back up into the industry.
You guys have rough drafts available every hour?
So I have, there's a couple, if you want to, I have a brand specific daily job log. They have a brand specific daily job log. If you want to give me your business card, or if you want to take my information, I have no problem sending you what I use, and you can take that copy and make it your own. And if you're spraying our product, by all means, you don't even have to rebrand it. Leave our logo on there so that way that helps you, right? There's a lot of ways to do it. The other thing you have to realize as an applicator, that's extra work for me, right? That's the biggest hurdle that you guys are gonna run into. Man, boss, dude, that's too much work. Well, maybe make an incentive, make it a line item on their pay scale. Hey, paperwork is X amount of dollars. If you do your paperwork, you get this, right? It's easy enough. It's not enough to where it's gonna hurt you. Let's say, hypothetically, big round numbers across your fleet, paying these guys an extra 20 bucks a day costs you $30,000 a year. If it will eliminate one odor complaint where the manufacturer supports the warranty, you're hundreds of thousands of dollars potentially, right? And as a manufacturer's rep, I hate being the bad guy. I don't want to come in and say, dude, I got nothing. I got no way to support you, right? That's a shitty position to be in, because the phone can present 100% right. If you can't even come to me and say how you processed that material that day, much less tell me whose product it is, I have to walk away. There's nothing I can do. So it's extremely important. And again, I feel like daily documentation is the most important thing that we can do outside of paying attention to processing and manufacturing the materials. Outside of doing your job at the gun and making sure you're installing a quality product, documentation comes second. Right? Obviously, protecting yourself is the most important thing. But that's it. Any questions? Daily documentation. Again, if you want information, if you want me to send you a rough draft, I will send it tonight when I get back to the hotel room. You can come up here, you can write down your phone number or email, and I'll get you what I can this afternoon. All right. It was a pleasure meeting you.